So, I finally upgraded to landscape instead of portrait mode, which means, well, because I have gotten a new setup that's just a bench vise holding a selfie stick. And I'll hopefully be recording better quality videos now, since I've cleared some memory after taking literally 10,000 pictures and videos. So today, this video will be about how I made my stupid thing that doesn't work. Today, I'll be showing how I made this amazing mini Tesla coil from a florescent circuit that I bought off of eBay for $20. Actually, it was bought for me, which makes it 100% free. Almost. So, I'll be going over how I made this as powerful as it is, what I can do with it, how it doesn't kill me. I think my Tesla coil messed up my phone. Let's do it again. Just kidding. Oh. So, my miniature Tesla coil started off as a $20 circuit, well, a $20, imagine this giant heatsink isn't here. It started off of this and a 9-volt battery. This is a $20 thing that I bought off of eBay. It was sold as a florescent circuit, or something like that. And the only reason I have the big heatsink on here is because that's the first, well, one of the first improvements I made. Originally, this is designed to be powered off of 9 volts. Actually, I haven't tested this yet, so I hope it still kind of works. It's supposed to light up fluorescent bulbs, which it doesn't seem to do. Maybe I might have connected it backwards. But yeah, it's pretty wimpy powered off of 9 volts. So, the first improvement I made to this low battery. But the first improvement I made to this florescent is to power off of 12 volts instead of the 9 volt battery that it's supposed to be powered off of. Simply, I took this wall adapter that outputs 12 volts at 500 milliamps and wired it up to the 9 volt battery clip. And so if I turn this on, you can see, maybe, that it produces the tiniest spark just off the tip. Which is it's actually funny how tiny it is. But it works, and like this, it should also barely light up light bulbs. And it also stops sparking when you do that. Wow, it picks up a lot better on camera. Off. In fact, this spark is so small you can only see it on camera in the dark. And I don't even know if you can see it. Just a blinking light there. And if I take my safety screwdriver... Yeah, it doesn't even spark when I touch it with that. The next improvement that I made to this florescent was to add a small 50 volt 100 microfarad, yeah, it's not nanofarad, 100 microfarad electrolytic, which it should be ceramic, but I didn't have ceramic capacitors, and this works fine, capacitor to the input of it, which helps, it increases the amount of power this can put out, because with a florescent that's just a transistor, the power goes down the more you try to draw power out of it, which is why it wouldn't spark when I put my, it wouldn't even arc to the screwdriver when I put it near that. And you can see this makes a big difference already. I wish I didn't take this out, because it's really hard to put in both the right direction and in the tiny breadboard holes. So, already you can see this tiny improvement makes a giant, well, this tiny modification makes a giant improvement. And now it will arc to me. And it also messes with my camera. Now this was actually sufficient for my needs as a science project at the time, so I didn't make any further improvements for a long time until I grew bored of the, well, they're pretty big sparks, but the smaller sparks in comparison to the new improvements. See, I can't turn it off, it messes with my camera. Around this time, one of the smaller improvements I did was add a top load, which was simply a 3-ounce weight that I found lying around. Now, that improves the performance a little bit, and I should showcase some of the things it can do. Which is light up small light bulbs and make X-rays with krypton light bulbs. Woo! It can light up fluorescent light bulbs from much farther away and much brighter. And it can make electrical fire inside of small... Oh, apparently it can't. Oh, there it goes. You can just barely do that to normal light bulbs. So, the next and quite simple improvement that I made is a common one among flare exciters or any Tesla coil, any form of Tesla coil. Simply inputting a higher voltage. So I got this 17-volt train transformer that outputs, well, like less than an amp. And it also has this dial thing so that I can adjust the voltage. So it's kind of like a variac, but not. And you can see that makes quite a difference in the spark length. But I decided then, hey, it's DC. I could actually just combine the two sources, the 12-volt and the 17-volt. And then shouldn't that give me, what, almost 30 volts? So I tried that. I also accidentally just did something. My 12-volt power supply has a capacitor in it, because it used a full bridge rectifier, and it's one of those old transformer ones. And so, I accidentally touched the wires together after it was unplugged, well, turned off. And they still spark. So, always discharge your capacitors. Here comes my favorite part. After some trial and error, I got the wiring working, and you can see, this makes a huge difference. It surprised me, actually, when I did it again. Now, in the dark, because it looks cool, this final improvement, wow, in real life it's a lot bigger seeming, can do the same things the smaller one can do. It can light up fluorescent light bulbs, only brighter. It can do this with ease on 2 different light bulbs. Woo. And it can do the krypton thing, which I'm not going to demonstrate, but it can also power an ion motor, which is the simplest form of motor. It just uses the sparks, the heat from the sparks, to propel this thing around and around. And, there are cool pictures of this, of Tesla coils, and that was a dumb... Me can't talks. I want to burn my finger, but I also don't. Oh, and there's one more thing. I have this old globe from a plasma ball, and it can light up that too. Wow, that looks awesome on camera. Bzzzt. So thanks for watching. Oh, one more thing. The final thing is that if you put a different, less spiky object on top, it'll make a lot of noise, like a normal Tesla coil. And this looks awesome in the dark. And it also burned my finger through the screwdriver. Thanks for watching. And let's look at another fun thing I decided to do with it. Wow, look at that. Ooh. Uh-oh. So I've been trying to build a spark gap Tesla coil, but I think I need to do more research on it, because even though this can produce some pretty gnarly sparks, Hello. That are even hard to look at. It does not run the Tesla coil, although capacitors can retain their charge and still kill you. Oh. Right, I can't resist burning my finger on it. Ah! Ah!